Okay, so this is a supplementary video for the radian measure and degree measure conversions. And so I just want to kind of make sure that we do some extra ones, like ones that I know last time what it was just converting radians to degrees. And we want to make sure that we can go back and forth. So yeah, I have another worksheet. It shouldn't take you too long. But I want to just kind of elaborate on a couple things. So let's do some further examples. So let's say I got a negative 690 degrees. Now that's obviously is, I want to talk about negative degrees, right? Like what does a negative angle mean? So if you remember from geometry, we always go counterclockwise in a positive motion, okay? And if we have a negative degree, that means that we're going to be going clockwise. So counterclockwise is our normal motion for angles that are positive, and then when they're negative, we go in the clockwise motion. Okay, so it's a little counterintuitive, but that's the normal routine. So we are actually going in the opposite direction here. So if I'm going to go negative 690 degrees, I want to be able to imagine this going well over 360, right? Because that's a full circle, and then I'm going to be not quite 2 times, because 2 times would have been negative 720. So I know that I'm going to be probably somewhere here in this fourth quadrant, but I'm actually turning in this direction. But that is irrelevant if you want to convert it to radians. All you have to do is just keep the negative sign. That's all that matters, because remember, we're breaking degrees from partitions of 360s to partitions of 2 pi, okay? Or we should say, really, we are breaking it from partitions of 180 degrees to partitions of pi, okay? So if I have negative 690, just keep it negative, and that'll translate into our conversion to radians. So remember, what I want to do is I want to get rid of the degrees, so I need to have degrees in my denominator, because that way those units actually cancel out, and that's a huge thing to remember. All right, so that's 180, and then we said that 180 degrees is actually pi radians. All right, so what we're doing is we're just, we want to be able to switch from one to the other. So we're going to get rid of the degrees, but we're going to introduce pi. All right, so then all you have to do is go ahead and take the negative 690 pi divided by 180, and then you just reduce the fraction. That's it. So automatically I can see that 10 will go into both of those. Then I know that 3 will go into both of those. That would be negative 3, that's 2, that's 23 pi. And 3 will go into here 6 times, and that's it. We're all done. So let me just tell you then, okay, that there's another way to look at this, and this is kind of the point of the video, that pi over 6, this partition here, pi over 6 means that I took 180 degrees and I divided it by 6. I hope you recognize that that's 30 degrees. Okay? Pi over 6 is a 30-degree partition. And how many 30 degrees do I have? Well, I've got negative 23 of them. And I just want to show you something real quick. Watch what happens when I multiply 23 times 30. And there's our 0, there's our 9, there's our 6. And because it's negative, we'll keep it negative. There. So what we're saying here is that this denominator is crucial. It kind of tells you the partitions of 180 that you're actually dealing with, okay? So pi over 6's are actually 30-degree partitions. And how many do I have? I have negative 23 of them. So I have negative 23 pi over 6's, okay? That is 30 degrees, okay? All right. So that's kind of a shortcut way of thinking that will really help you in more advanced mathematical classes. All right, so let's just do one more for the road here. There's 210. I want to convert that to radians. So I will take pi over 180 degrees, right? Pi over 180 degrees. The degrees units cancels out. I get 210 pi over 180. 10s will cancel that out, and then 3 will actually go into both. That will be 7 pi, and that would be 6. Okay, so now I have 7 pi over 6's, okay, which means I have 7 30-degree angles, okay. All right, so now let's go the other direction. All right. The other direction is when I have, let's say, negative 9 pi over 4. Okay, so now I have pi over 4s. Okay, now pi over 4 is not a 30-degree partition. Okay, pi over 6 is a 30-degree partition. Pi over 4, let's go ahead and divide 4 into 180 so that we can see what we're talking about here. 4, and then that's 16, that's 2, drop the 0, 45. Okay, so it means that pi over 4 is 45-degree partitions. Okay, so the way to visualize this, okay, now I'm going in the negative direction. That's a pi over 4 because that's 45 degrees. I'm going to cut these quadrants into pi over 4s. Okay, that's 45 degrees. That's 45 degrees. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. That is negative 9 pi over 4. Okay, that's how I can draw it. That's what I should be doing, visualizing that. Okay, but it still does not convert it into. I know it's going to be over negative 360 now because it's clearly over that. Okay, so I broke it down into pi over 4 partitions and just counted my way around it. But I'm going to just go ahead. If I'm a formula kind of person, I want to now get rid of the pi and introduce degrees. So now the conversion factor has changed. I've gone from dividing by 180 here to actually dividing by pi and introducing degrees. Okay, so I want to eliminate the pi, but I want to actually keep the degrees because that's what I'm converting to. All right, so my degree unit should stay. So now what I have is I just have a fraction here. I try to figure out. I know I'm going to have negative 9 times something, but I know 4 will go into this, maybe not evenly, but something. So 4 goes into their, let's see. 4 will go into their, brain freeze. Okay, 45 times. Okay. So that's 4 goes into 45. So negative 9 times 45. Okay, that's 4, that's 4, so remember that's negative, so negative 405. All right, so negative 405 degrees, yeah, sounds about right. Okay, the estimate makes sense. All right, that's the quick and dirty, but I also want you to visualize what's actually happening, because if you just stick to the formula, you forget how to do it again. You know, if you just memorize a formula, it's just not good enough. But just notice that the formula for converting back and forth is either pi over 180 or 180 over pi. I mean, it's that simple. Okay, you can always do that when you are trapped. Okay, but this is a good, important visualization to look at these partitions. That's extremely valuable in visualizing and actually remembering what's actually happening. Okay, so now I got this crazy one here, 83 pi over 18. Okay, well, now I have a pi over 18 partition. Well, let's see. I know pi is 180 degrees. So if I were to divide it by 18, okay, that's just 10. So it looks like this right here, that's a 10-degree partition. Okay, pi over 18 is 10 degrees. And how many do I have? I have 83 of them. So that means I have 830 degrees. That's simple. That's my answer. But let me show you, in case you forget, like how this is operating here. I'm going to just use the formula. I'm going to get rid of the pi, but I want to introduce degrees. Okay, so 18 goes into here 10 times. Pi's cancel out. 83 times 10, 830 degrees. Okay, but the whole point, though, is to kind of ignore this number there and focus on what kind of partitioning am I doing? What am I doing to pi, and how many do I have of them? I think it's just the best way to visualize what's going on. And in the long run, I think it'll help you a lot when you go into more advanced mathematics. All right. Okay. So I got 20 more of these questions. Just give them a shot. I'm going to put it out there. Obviously, there's no due date. Just keep yourself sharp. Keep learning. This stuff is good for your soul. All right. And it's a good distraction, you know, kind of start to worry about stuff, you know, feel isolated, nobody's returning your phone calls, none of your friends want to talk to you. I'm kidding. Anyways, that's it. All right, so I'm going to go ahead and upload this in the worksheet, and you guys be safe.